Hello everyone and welcome back. In today's lesson, we are going to walk through the construction data section. That's here at the very bottom. In other videos, we've covered the design condition section. So I have a video where I go over all the information, how to figure this out, what all these points mean, inside design temperature, what does that mean? Where do we find this information outside design temperature? So please refer back to that video called Design Conditions if you have questions. Also, other videos covering Table A and Table B. In this video, we're going to cover construction data. And this is the last chart to figure out basically the BTUs that we need for heating and the BTUs we're going to need to remove for cooling. But before we can calculate the cooling BTUs and the heating BTUs, we need to find out some information about the building and the dimensions of the building, specifically these different areas or parts of the house. And this is really foundational to load calculations. So load calculations, we're trying to figure out what is the load of the building and how much air conditioning or how much heating do we need to keep up with that load. Every building has a different load because the structure of that home is built differently. Every commercial building is built differently. And so we have to look at the construction physical dimensions, the construction materials, and that's called construction data. So if we get this part wrong, the rest of the calculation's not going to be accurate. If we get it right, everything's going to start lining up the way it should be. So let's take our time and go step by step. So the construction data section records really details about the walls, windows, doors, ceilings, floors, and other components that make up the building envelope. An envelope refers to a barrier in the home that separates the outside from the inside. So look at the building envelope or a home envelope as a wall or a perimeter that on the one side of the wall you have inside the house and the other side of that wall is the outside. So that's the envelope, right? And in between those two spaces, you're going to have a huge temperature difference during those winter months or summer months where you'll have the highest extremes of temperature difference. And each piece of information we get from the house that we measure represents that surface area. And that surface area affects heat loss or heat gain. And that basically means where heat can either leave the house or where heat is going to enter the house. So when we talk about heat gain and heat loss, another way to look at it is how is heat going to enter the home in the summer and how will heat leave the home in the winter. Now, heat will always be moving. Remember, the law of thermodynamics states that heat will flow from a warmer place to a cooler place. So that means heat will always be moving, even though we have insulation in the walls, in the attic, we have energy efficient windows. Heat is still going to be trying to transfer or move because of that simple law that says heat has to find a place that's cooler. So because we have that temperature difference in a home, that's our battle, that's our struggle, right? And so we need to find the dimensions of the home, of the walls. And then after we find the dimensions of the house, we're going to find the R value, in other words, the material, the construction material that they use to build that home. And because that has a R value or U value, and those values basically represent the resistance to heat transfer through the walls or material. And so let's begin first with the gross walls. How do we measure these gross walls? Like, what is this gross wall? So I'm going to pull up a simple plan of a home. So this is a set of plans or drawings of a home, and I'll just kind of walk through this simple plans. Is we have a master bedroom. This is a 2-bedroom home. We have a master bedroom on the right side over here with a master bath, shower, and walk-in closet. It looks like a split wing. And then you have your living room and kitchen area with island. You have bedroom number 2 with closet, hallway, utility, so like a laundry room, and then it's like another bathroom. So if we look at this home, when we're cooling or heating this home, the cooling is going to take place inside the house. I mean, this is pretty the basic idea, right? You go inside your house, you want to be comfortable. And when you heat the home, you're going to be heating inside the house. Like our air conditioning equipment isn't designed to cool outside the house. We don't care for heating the outside of a home or heating the outside of the home or cooling the outside. We want our heating and cooling to be directed inside. So what does that mean? We want to keep that heating and cooling inside. So this wall that separates the outside from the inside is called the building envelope. And it's just all that means is it's this wall separates the inside from the outside. And how does it do that? Well, they use construction material that's supposed to resist heat transfer. Now, heat transfer is going to, like we've said, it's going to take place, but it's going to resist it. So R value stands for the resistance to heat. U value stands for the conducting of heat. And if we haven't covered that term yet, conductance, or there's 3 ways that heat can transfer, is conduction, convection, and radiation. Conduction means heat moving through physical material, and convection means heat moving through vapor or liquid, like the air. And the third way heat moves is radiation, which is through space. Like, in other words, heat can, like the sun, when you stand in front outside and you let the sun hit your face, you're feeling the radiation from the sun. So that heat is traveling through space and it's directly contact with your face, warming your body up, right? And wherever that sun is touching, you feel the radiation heat. So all 3 of those types of heat are taking place on this building envelope. And that's really where we want to calculate our heat gain and heat loss. So how do we get the wall measurement? Well, first we have to measure, and you can do this 2 ways. You can go out to the building, the home. You could take a measuring tape. You can physically walk the home with the measuring tape and measure the home. Or if you have a set of plans or drawings like this, you can just go off of the plans and drawing, and you can add everything up. So if we look at this home is 32 feet. So this 32-0. So this is 32 feet on this side. And guess what? It's typical, or in this set of plans, it's going to be 32 feet on this side as well. So we have 32 and 32. We're going to add all these up. So 32 plus 32 is 64. And then we have this side of the house that we have to add up. So the width of the house, so the porch is 38 feet by 6. We don't care about the porch. We care about the width of the house. So the width of the house is 40 feet in length on this side. We're going to go across the north side of the house, and this is going to be 40 feet as well. So 40 plus 40 is 80. Let's add it up on paper real quick so we can see what's going on here. Okay, so we have a total of 32 plus, plus 32. So those are the 2 sides of the house. And then we have 40 feet plus 40 feet. And let's put that in our calculator. And that's going to give us the total perimeter of the wall. And I'll show you how we're going to come up with the gross wall here in a minute. So we go 32 plus 32 plus 40 plus 40. So our total perimeter is 144 feet. So if we go back to our plans, if we were to walk this out with the tape measure, measure 32, 40, 32, and 40, it comes out to 144 feet. Now, how do we get the gross walls? Well, length times width equals area. So we have the length, now we need the height. I said width, but it's going to be height. So we have 144 feet, linear feet. Now in this case, we're going to just say that these walls are 10 feet tall. So what we're going to do now is we're going to take our 144 linear feet that we walked out with the tape measure, or we measured with the plans, and we're going to times it by 10 feet. And that's going to give us our area of the walls. That's gross walls. So 144 times 10 equals 1,440 square feet of gross walls. So square feet. So now we can take that 1,440 square feet. Let's see, go back over here to our worksheet. So our gross walls is going to be 1,440 square feet. Now, if you notice, there's two sets of gross walls on this construction data section. You have gross walls and then you have gross walls. So the reason why there's two sets of walls that you have an option right now, we're just going to do a simple set. So we're going to put NA. We're not going to use it. But if you did need to use it, the reason why you have two sets of gross walls is because if you have a set of walls in this house or a house, and it's a different kind of construction material, in other words, let's say you have stucco walls, R12, 2x4s, and you're measuring that wall, let's say on the first floor. Let's say the second floor has some type of different kind of structure, a different type of wall. There's different measurements for that wall that you want to use because that different wall has different construction materials. So because it has different construction materials, it's going to have a different R value. But most homes typically have one kind of wall, right? It would only probably be a custom home where you would see two different types of different materials for a house to have in a wall. So we're going to leave that one blank. And so how do you come up with the net walls? All right, so we already talked about the doors. Where do we get that from? We get that from the table A or table B. So the windows will allow heat to enter and leave the home differently than the wall will. So to figure out net walls, all we have to do is subtract 197 square feet, so that's the window area, from 1,400 square feet or 1,440 square feet. So go 1440 in your calculator minus 197, you'll get 1,243 square feet. So that's our net walls. And remember, the second net walls, we're not using that. Excuse me. Okay. And the ceilings and floors. So the ceilings and floors are pretty simple. Let's go back to our floor plan. So we need to find the area of the floors and the ceiling. So the floors is the area of what's underneath you, right? That's the section that you walk on, the floors. Could be concrete, it could be a raised foundation, but we need to give an area, a measurement of the floors. So how do we figure out the area of the floors of this house? Well, again, this house is pretty easy. Area is length times width. So the length of this home is 40 feet and the width would be 32 feet. So to figure out the area of the floors, you simply go, in this case, 40, because you can see the width of the home is 40 feet, times the depth of the home, so length times width, or width and depth, same thing, times 32 equals 1,280 square feet. Well, before we go on to the ceilings, typically whatever the floor area is, you're going to have the same ceiling area. Think about it. You're in your house, you're in your room, look at the floors. You have a certain area on the floor. Well, the ceiling is going to be almost identical, if not completely identical. The only time it would be slightly different is if it was a vaulted ceiling. We won't get into what that is necessarily right now. We're going to keep it very simple and basic. But generally speaking, whatever the area of the floor is in the home is going to be the area of the ceiling. So this 1,280 square feet for the floors is going to be 1,280 square feet for the ceiling. So let's go back and enter that information now. So the floors, right, we did that, 1,280 square feet for the floors. And to enter 1,280 square feet for the ceiling. And that's it. That's how you find the construction data for the home. Once all areas are measured, and once you've recorded everything, you've measured everything, and you've entered it into this construction data section, you want to double check your work. Now, of course, when you're doing the actual measurements of the home, when you have that measuring tape out and you're looking at the measuring tape, put your eyes on that measuring tape twice. Make sure that you're reading it correctly when you're writing this down on your notes. And then when you transfer it over to the paper where you're actually multiplying or figuring out area of the gross walls, length times width, double check your math as well. Take the time to make sure these steps are accurate. Another way you can check once you have all this information now filled out, if you add the windows and doors square feet by the net walls square feet, it should equal gross walls square feet. And that's another way to double check your construction data information that you've entered into this section. And of course, ceilings and floors, length times width of the lay of the footprint of the home. And so to recap, the construction data section of the worksheet is about carefully recording all this information accurately. And once this information is accurate, we're ready to move on to the calculation side of this worksheet, which is over here in the heating section and the cooling section. But that's it for this section on the construction data. If you have any questions, send me an email or you can ask me in class. But hopefully this video clarifies this section. It's pretty straightforward. Is really just have to understand how to look at a set of plans or a building, and of course work in the formulas like area, length times width. All right, everybody, have a good night. I'll see you later.